That's not in your way, is it?
Oh, you're good. I can do the first.
Okay, guys, let's try this problem. This is theoretical. What I want to say about this, I will probably ask you something conceptual and theoretical. It will not just be a plug and chug exam 100%. It'll be mostly like that. But I may ask you some things where you have to explain something. I think I said last night I'm not going to do true-false with you, but I might give you statements that are true and ask you to explain them. Or I might ask you to give me an example of something that's not true. Okay? Not a lot of that kind of stuff, but it's particularly well suited to the linear algebra stuff, such as this example here. Okay? So, and I have to warn you, the study group on Sunday night, they just nailed this one for some reason. So we've got high standards here to meet up to. But the reason that, one of the things that helps you to nail a problem like this is if I give you a hint. So I'm going to give you a hint here. The hint on how to do this problem is determinants. One word. Okay. So that's my hint.
I get it.
Does that help?
That's funny. Of course that's the hint.
Well, we're going to use determinants. Anybody have any idea? So we have a couple of invertible matrices. And I know that AB is negative of BA. Right? We know matrices don't always commute, right? So there could be a minus sign. Yeah.
So does that mean that negative BA equals the identity matrix?
Oh no. No, we're not saying that this is equal to the identity or that this is equal to the identity. We're just saying they are equal to each other.
Oh, okay, I'm sorry.
They're equal to each other.
They're not.
I mean, I guess another way to write the equation would be AB plus BA is equal to 0. You could write it like that.
Right now, I misread that as
That's
they
okay.
were inversely.
Yeah, no problem. That's just a minus. So this is the equation. Right there. Any thoughts on what I could do? The hint is to use determinants. It's one of those very abstract problems. Go ahead, Bryce.
Is it because the way the plus and minuses are ranking each other? Like
That,
within
you know,
the matrix?
with the cofactors and stuff,
Yeah.
that's actually a little too specific.
Okay.
That's getting into the nuts and bolts of the entries of the matrix.
Okay.
See, we're trying to get away. This is a problem where we just have capital A, capital B. We're not really looking at the detail.
All right.
That's a good idea. Anybody else have any thoughts here?
Would we have to draw up a matrix and just give an example of something?
Okay, that's a good point. Can we just give an example here?
No.
Not because if something was not true, I could say, give me an example to show me why it's not true. But if something is true and I want an explanation, you have to. So if I make a statement like, I think I've used this example before, all Saturdays are sunny. Right? If I tell you that, and I take you outside this Saturday and it's sunny, does that mean that I was right? All Saturdays are sunny? It doesn't. And it's the same way here. If you give me one example that works, I might say, oh, you got lucky. Just like this Saturday I could get lucky. It could be sunny. But it doesn't convince me it's always like that.
Yeah.
Is it really?
Yeah.
Oh, wow. Oh, wow. We need it. Okay, so anyway, we need to actually do this more abstractly. Another idea. Miguel, you had your hand up a minute ago.
Yeah, I lost it. Sorry.
I'm sorry.
Will we use the fact that the determinant of A times B is equal to the determinant of A times determinant? Are we splitting up
Oh,
determinants?
that sounds like a promising thing to do. In other words, Zach said, what about the determinant of AB? We do know, I mean, it makes sense, right? Because this is the box equation and this is the hint. So this is about all you can do, right? Now, we already know that can be split into two parts, right?
Yeah.
But before I do the splitting it apart thing, what I'd rather do is just say, look, this is the same as the determinant of negative BA. Guys, if two matrices are equal to each other, then their determinants are certainly equal to each other. So if these two matrices are the same matrix, they're equal, then the numerical value of the determinants, they're equal. Agreed?
Would we say we're determining both sides?
We're determining both sides. The collector will say that. Determining, we're taking the determinant of both sides. Okay? Why are we doing that? Because it's the hint.
Literally all we're gonna
Okay, now we can get in, but now we can sink our teeth into this and say, oh, this looks like something we've talked about in class, right? So what is the determinant of AB? Good, determinant of A times the determinant of B. Excellent. And how about on the other side? Determinant of negative B times the determinant of A, right? That look all right? Like it. Okay. And now, the thing, guys, about the determinant is it's just a number. So when you're dealing with numbers, things are a lot easier to deal with, right? So you were going like the... Because you want to do what? Cancel what? Why can I do that?
Because the numbers?
It's not zero.
Because they're numbers. Okay.
Wait, no, I take it back.
No.
Never mind.
These are equal, right? I'm going to cancel a number. They're not equal anymore. Be careful. You can't divide by 0. So determinant of A, can I divide by
It
that?
can't equal 0 though because they're invertible?
Exactly. See, the pieces come into place as you work your way through it. The matrices are convertible, so the determinants are not 0. So you can safely do that. Okay, so since the determinant of A is not 0, cancel. And by the way, guys, I don't even know, I mean, this isn't even what I'm trying to explain yet. I'm trying to explain why n is even. And I have no idea what this has to do with that yet. But let the proof come to you. Just work through what you know, right? So cancel to get determinant of B equals the determinant of negative B. All right. Now, this one here, can we simplify it? To what? Negative the determinant of B? 1. You already know this. Look, here's the thing. Let's say that's right. Let's say that that's correct. Then what are you going to do next? You're going to cancel determinant of B for the same reason. Still invertible, right? Still a non-zero number. And what are you going to get? 1 is equal to negative 1, and you know something went wrong. Because that's not true. So what did we do wrong from here to here? Let me ask you this question. If it was the determinant of 2b,
Oh, so this would be the
how would you simplify this?
2 times the determinant of B.
2 times the determinant of b?
No, it's going to the n.
2 to the n, right? These are n by n. Remember, guys, when you multiply an entire matrix through by a constant, each row is picking up that scalar factor, and there are n rows. So each time you do that, you get another factor of that constant. So what am I going to get here? Negative 1 to the n, right? Yeah, negative 1 to the, oh my gosh, now I see it. Now I see it. Do you guys see it?
Yeah.
Cancel and cancel, right? So cancel again. Cancel again, you're going to get negative 1 equals negative 1 to the n. We have it. Because, what do you know about n if negative 1 to the n is negative 1?
That would be 1, not negative 1.
Yeah.
Oh,
I
I'm
think
sorry.
it's 1
That
equals
should have been 1.
There we go.
Sorry, screwed that up badly. Okay, So negative 1 to the n equals 1. So what's that tell us?
And that's
N is even, exactly. It has to be a 2 by 2 or a 4 by 4 or a 6 by 6. It cannot be. You cannot have a 7 by 7 set of matrices for which that happens. Yeah.
Yeah, that constant inside the determinant thing, that came up in group work as well with the 2 to the n. No, yeah.
This one.
Yeah.
Yeah.
Can you what's the plane
What's the what?
what's the equation to remember or to remember that? Just in the
The general formula is this, Daniel. If I have the determinant of k times a, that equals k to the n times the determinant of a.
okay.
That's what I
Yeah, this is a good one to memorize, but if you know your ERO steps, it's not so bad. Okay, are we good on that one?
Yes.
All right. There's only 3 more to go, 2 of which are quick, so we're not that far from being done. Let me go backwards to number 3. So I might ask you something. What I might do actually is give you like a choice. Sometimes the trouble with these proofs and explanation problems is sometimes you sort of either see it or you don't, and you can stare at it forever and it just does not come to you if you're just not clicking the right way about it. But sometimes what I'll do is try to give people the choice to say, well, you don't have to solve all of them, but find something that you can do, on these theoretical type of problems. It will not be worth a lot of points on the test, okay? But I probably will ask something kind of semi-theoretical. I don't want to just make it a mindless plug and chug experience.
Well, I like the way you did the sample test. You gave us 4 and you said pick any 3.
Is that what I did?
Yeah.
Okay. Yeah, that's the kind of thing I'm kind of fond of doing. Okay, here's another one. This one's quick. You guys already know how to do this one, I'm sure. Number 3. A is a 4 by 4. B is a 4 by 4. And the determinant of A is 2, and the determinant of B is 3. So here is the question. Find the determinant of A inverse B quantity transpose times 2B quantity inverse. So why don't we have everybody try that one? I'm going to give you like 60 seconds. Do it on your own. Take 1 minute or so, and we'll see what answer you get. Properties of determinants. Thank you. Anybody have an answer?
8.
What did I hear?
36.
36?
Yeah.
Anybody else got a idea?
1 over 32.
Say again?
1 over 32.
2? You just guessing?
No.
2 ninths. Okay. Anybody else want to crash and burn? What did you say?
Kidding, but not.
The right answer actually is on the board. Okay. So let's figure this one out. the key thing here, guys, is you have a multiplication in the middle. So that means you can focus on the determinant of the two parts separately, right?
Yeah.
Now let's talk about the first part. On the first part, we have a transpose of something. Does that matter?
Not yet.
Not for determinants, right? So I really just have to think about A inverse times B. And that's a product as well, right? A inverse times B. So the determinant of B was given as 3. What is the determinant of A inverse going to
It's
be?
1 over 2. Or 1 over 2.
It's the reciprocal of the determinant of A, right? So that's another one of our properties I guess I didn't write down earlier. So this is the form. So we get 3 halves for that, right? For this first part. 3 halves? Everybody comfortable? That's half of the thing we need.
Yeah.
Okay, now let's look at the second part. 2b quantity inverse.
I didn't.
So this is an inverse, right? It means it's a reciprocal of the determinant of 2b. So it's 1 over the determinant of 2b, which is
2 to the 4 times 2. Yeah, to the 4.
Two. Okay, what was our formula? Alexander, what was our formula over here?
Oh, A or K.
1 over K.
Yeah.
Right. So what is n here?
4.
4. So what do we get for the determinant of 2b?
2 to the 4 times 3.
2 to the 4th times 3, right? 2 to the 4th times 3. Everybody got that?
Can you explain that again?
I'm not doing the, okay. I'm not doing the inverse yet.
Okay.
I'm just looking at 2b. What is the determinant of 2b? The answer is it's 2 to the 4th, I'm using that property right there, times the determinant of b, which is 3. And that comes out to 48, right? So that's a 48, but then I have to take the inverse of that, which is 1 over 48. So what is 3 over 2 times 1 over 48? This is the answer.
I forgot to invert it to the 4.
Right, so be careful, guys, with these. There's some good ones to practice in your group work and elsewhere. But this sort of thing, if I ask you something like this, you should just think of it as this is not a tricky problem. It's just a matter of knowing your rules and being able to apply them, in step by step. So, okay, so that's the answer, 1 over 32. Everybody good with that? You guys can make up problems for each other. Like you can write one, just make up something on your own. You can use 3 matrices, A, B, and C, and do some crazy combination. See what you get. All right, I'm going to jump to problem number 1 on the sheet right now because I know some people are going to want to go. The thing that we haven't talked about at all, really, is the differential equation. So I'm going to talk about that a little bit. So here is a differential equation, 2xy, y prime, equals 4x squared plus 3y squared, and what we want to do is solve that. So what's the very first thing that you would want to do here?
Change the y prime to dy dx.
Change the y prime to dy dx? Okay, I didn't hear what did you say, Daniel?
Divide by 2xy.
And divide by 2xy. Okay, we can do both of those things at once. So I'm going to put the dy dx, which is the y prime, on the left, and I'm going to divide everything else onto the other side. Okay? You like that? Okay. Now what?
That looks... Separate them.
Go ahead.
I canceled that.
That would make
Separate.
do 4x squared over 2xy plus 3y squared over 2xy.
Okay, 4x squared over 2xy plus 3y squared over 2xy.
Yeah.
And then, of course, that could be reduced because 4 over 2 is just 2. So this would be 2x over y, right? 2x over y plus 3y over 2x. So we could also look at it as that, right?
Yeah.
Okay, now what?
Subtract the...
Hold on. No?
Isn't it homogeneous?
Isn't it homogeneous? Yeah, so that's the question we could be asking ourselves. Is this homogeneous?
Yeah.
If you put t's next to every single x and y, they all cancel out, so it's homogeneous. Now, what were you suggesting, though?
Actually, no. I was doing.
I like what you were about to say, actually.
I was going to subtract 3y over 2x to the other side.
I'm going to write it like this.
Oh, yeah. You get a Bernoulli like that, and then you get a Bernoulli and remove the y.
Guys, it's both homogeneous and Bernoulli.
Yeah.
This is either one. Take your pick, right? If you write it like this, it's kind of obvious that it's homogeneous.
Yeah.
But if you write it like this, it's kind of obvious that it's Bernoulli with an n of -1, right? Because this is like y to the -1 power. So we now have a choice to make, and we can choose both. We have several options. We can solve it the homogeneous way, we can solve it the Bernoulli way, or we can solve it both ways. Preference for what I do first? Bernoulli?
Both.
Both. Okay, you want to do both. Okay, can we do Bernoulli first?
Yeah.
Okay.
Sounds great.
I want to do Bernoulli first only because the other night I only did the homogeneous way, and so just to keep myself entertained, I want to do it the other way. And you guys, this will review some of the important formulas, right? So for Bernoulli, what do I need to do first?
Do the y minus or change variables.
Sorry, what's the first thing I want to do?
Change variables.
Okay, change variables, but even before that,
Write down what u is.
okay, even before that, what is n? Yes, I'd like to write down n. What is n anyway?
-1.
-1. You need that to do the change of variables.
Yeah.
Right? So the change of variables is u equals y to the 1 minus n. This is one of your formulas to remember on your sheet, right? So if I put in -1 for n, I get y squared, right? So after I solve for u, I'll have to take a big giant square root of it to get what y is. In other words, y is equal to the square root of u here. Yeah, okay. So that's my change of variables. Now what do we do next?
U prime plus 1 minus n p
And
of
1
x
minus n is 2.
is 2.
So I'm going to plug in the 2. So it's 2 times
P of x.
p of x. What is p of x over
3
there?
over 2x.
Oh, we're gonna cancel your
Times u.
Need a
negative.
minus sign.
Negative,
Please be careful. The minus is actually part of the p of x, right?
Okay.
So we need a minus. I'm going to change this to a minus right here. Okay. Good. Times u. Good. Equals.
2 times 2x.
Right. 2
Which is
times 2x, which is actually 4x. And do we put the over y?
No.
No, because we converted to the new variables where we don't have the nonlinear part. So it's just literally 4x. Okay, good. So let me just simplify this really quick. This is just u prime minus 3 over x times u equals 4x. This is my new equation. If you can get this far, you'll get partial credit. You'll be well on your way to solving it. That's a good start. Okay, what do I do next?
I have
This is linear now, so I need an integrating factor, right? So the integrating factor, that's the capital I. Anybody remember the formula for it?
e to the integral of -3 over x.
E to the integral of negative, and I'm so glad you said negative, 3 over x dx. Please do not forget, you have to keep the minus sign in that integral if it's subtracted. Minus sign comes along. Okay, good. So does everybody know what that's going to be?
-3 of x.
You do this enough, if you do it enough, you already know that the integral of 1 over x is ln of x, and the -3 goes up as an exponent, and e to the ln cancels. So it just becomes x to the -3. Can I get away with doing it that fast? Everybody can do that? Okay, super. So that's my integrating factor. Now do you know what goes next?
integrating factor times
The integrating factor, 1 over x cubed times u,
quantity derivative.
the derivative of the product, we made a product rule out on the left side, equals
The integrating factor times q of x.
the integrating factor times q of x, which my new q of x is here. It's 4x, right? So it's going to be 4x over x cubed, or in other words, 4 over x squared. Okay? Let me know if I'm going too fast here.
Why is it 1 over x cubed and not just x cubed?
It's because of the minus sign.
Oh, yeah.
Yeah, the minus sign causes that to happen. Okay, now what do we do next?
Integrate.
Oh, incidentally, one more thing. When I did the integrating factor here, did I need to put a plus C on that integration?
No.
Not at all. When you're doing integrating factors, you do just choose C to be 0, basically. But down here, I'm going to use the plus C. So I integrate both sides. I get 1 over x cubed times u equals, what is an antiderivative of 4 over x squared? You know, I don't like negative exponents, but when I'm integrating, I do. So integrals, you raise the power up by 1, right? So x to the negative 2 will go up to x to the negative 1, divided by negative 1. This is not going to be in your table, guys. This is a basic power rule backwards. Negative 4 over x is what you should have. Of course, and plus c. You can always, of course, check by differentiating negative 4 over x that you get 4 over x squared back again. Anybody having any issues with that so far? Okay, so we did that. Now what do I do next? Multiply this x cubed over, right? So I'm going to solve for u, basically. So when I do that, I'm going to get negative 4x squared plus cx cubed, right?
Yeah. And then change your u back to that.
And u is just simply y squared. Okay, everybody with me? U is just y squared, so y will be the square root of that. Negative 4x squared plus cx cubed. I guess we should allow a possibility that could be the plus or minus the square root of that. I would probably not fuss with you over that. I would give you some condition that makes it positive. Okay. So plus or minus the square root of negative 4x squared plus cx cubed. That's the answer. That's the answer. By the Bernoulli method. This is the Bernoulli approach.
Would homogeneous give us the exact same
Let's do it and see. We're going to check our work. I don't recommend this on the exam. You'll run out of time. Don't solve problems 3 different ways. But I'm gonna do this one in the homogeneous way. So this is homogeneous here, right? We've already established that. So I'm going to do it the homogeneous way. Homogeneous way. So that means we have a particular change of variables that everybody needs to know, right? What is it?
V equals y over x.
Okay, v equals y over x, or in other words, y equals x v. Okay, and then what do we do from there? Okay, take the derivative, good. The derivative being, in this case, good, plus v. Great, all right, so we got that. And now the trick is to start plugging everything in. And the y prime is here on the left side, so I'm going to replace that with, so I'm substituting in now, I'm going to replace that with x v prime plus v equals, you know what, it's actually easier to just use this over here, because the y over x can just be replaced with v, and this is 1 over v. So it's really just 2 over v plus 3v over 2. This is your equation. Agree? And yeah, remember that a homogeneous equation is always going to become separable. Now we might have to do a little algebra here to get it to look that way. Speaking of which, so does anybody see any algebra here that they particularly think we should do? Melissa, maybe do you see any algebra we can do? Kind of hear from everybody. Can you combine anything? I think so. Yeah, the v's. So I have a v right here, and I have 3/2 of a v over here. So don't those sort of balance out partially? Right? So actually that's exactly right. So it's x v prime. I'm going to just cancel this v to the other side. So it'll be 2 over v plus v over 2. Agreed?
Make v prime equal to dv equal to dx.
for the purposes of separating variables, it's just a little clearer to people usually if I use the Leibniz notation right here. Okay, so I rewrite v prime as dv over dx. Okay, equal 2 over v.